Okay, so 231, comparing linear and exponential functions. All right, so the first thing that we have here is that we have a couple graphs. You can see that these are called nonlinear and these are linear. So we got a couple graphs here and a couple tables, right? So if we look at these more closely, you can see, right, that this increases at a pretty steady pace, right? And it is a straight line, okay? In fact, if you look and recall back from Math 8, this actually goes up and has a slope, right? If you look at the dots here, has a slope of 3 over 5. 1, 2, 3, 4, 5. Yep. And same thing again to get to that point, right? So it goes up 3 over 5. So that would be your rise over run. And you're adding, right? Same thing here, straight line. That's what makes it linear, okay? And then on the tables, the idea is that it goes from -7 to -4, -4 to -1, -1 to 2, and 2 to 5. So how could we say, or what could we say the pattern in that is? Well, it's adding 3 every time, right? And so that's what makes it linear right there, is the fact that it's adding every time. Okay, same thing here. To go from 7 to 9, that's adding 2. 9 to 11, that's adding 2. 11 to 13, that's also adding 2, right? So that's what makes a graph or a table linear, is that it's adding or subtracting by the same number every single time. Okay, the following functions are represented by graphs and nonlinear. So you have this one, right, which is curved and starts really, really small and then goes up very quickly. And then this one, it starts really high up in the air and then slows way down and gets really close to the x-axis, right? And so then you also have these tables. Okay, well, let's see if we can recognize the pattern. These are actually called exponential graphs. Okay, they are nonlinear because they don't make a straight line. And in this table, you can see that to go from 2 to 4, I would add 2. And 4 to 8, I would add 4, right? So since that's not the same addition, we could then say, well, another way to look at this is 2 times 2 gives me 4, and 4 times 2 gives me 8, and 8 times 2 gives me 16. And same thing here, 5 times 3, 15 times 3 gives me 45, and 45 times 3 gives me 135. So you can see that for it to be a linear graph, it needs to add and subtract. For it to be nonlinear, and specifically, these ones are called exponential, it needs to multiply or divide. All right, and that's exactly what the observations here need to state. So linear functions make a straight line on a graph and increase or decrease by adding or subtracting the same number. Okay, whereas exponential functions make a curved line on a graph and increase or decrease by multiplying or dividing the same number. So you can see straight line, curved line, adding and subtracting, multiplying, dividing. And we call that, in linear functions, that number that we add and subtract by the same every single time, we call that a common difference. Okay, so that's called a common difference. And again, if I'm moving too quick, feel free to pause the video so that you can get this copied down. In a linear function can be written as f of x equals mx plus b. And you may recall this from previous years of math, but this is y equals mx plus b. Same thing, right? Y is the function of x. Okay. Exponential functions then increase with a common ratio, meaning they multiply together, right, making their graphs curved. Exponential functions are represented as f of x equals a times b to the x, where a is the initial value and b is your ratio. Okay. All right, so let's try a few other examples here. Determine if the following functions are linear or exponential. So in this first table, go 1 to 3, 3 to 5, 5 to 7, 7 to 9, 9 to 11. That is adding 2 every time, so that would be linear. My handwriting's superb today. Table 2 looks like 1 to 2 is plus 1, but 2 to 4 is not plus 1. So instead, it's times 2, times 2, times 2. So this one is exponential. I'm just going to say expo for now. Okay, this is a straight line in graph number 3, so that one would be linear. And then this one is an exponential where it goes from really small to really big, right? So that is exponential. Okay, so when you're comparing those two type of functions, like we have in this next graph, right, you have this red function, 2 to the power of x, which is this. Okay, we can clearly see that that is a curved line, and it starts slow and goes up really quickly, so we call that an exponential function. And then g of x, which is this blue line, is like this, and it just looks to be straight, unless of course you're getting the optical illusion, but this would then be linear. So g of x is linear, f of x is exponential in this case. Okay, remember that f of x and g of x, that's just another way to name a function. So then it says circle which function is greater on each of the following intervals. So where x is less than -2. Okay, so -2 is right here for the x value. Okay, so on this side, this is x is less than -2. And I would say that the red line, or f of x, is greater on that point. Okay, then it says from -1 to +1. Okay, well, -1 to +1, that's going to be from right here to right here. It's that interval, right, that domain. And as you can see, we have the blue line on top there, which would be g of x. Okay, and then lastly, it says for x is greater than 2. So I'm going to change that as well. And that's, oops, it's going to be right there where I already started marking a line, of course. Okay, and it goes this way for x is greater than 2. And as you can see again, the red line is back on top, so that is f of x. Okay, so just kind of looking at those graphs, that's how you determine which one's bigger. One of the observations that we can make is that while the linear graph is steady, the exponential usually starts a little bit higher and ends higher, right? It goes up much, much faster. Okay, so it says write the inequality for the domain where f of x is greater than g of x. So f of x is the green, right? Well, the green is bigger on this left-hand side. So that's going to be x is less than, and that x value is 1. Right, so x is less than 1. And then where is f of x smaller than g of x? It's on the right-hand side, so that would be x is greater than 1. Right, because that's where g of x is on top. Okay, last one, pretty quick notes here today, and again, you could always go back and recopy this down or pause if you need to, but I want to keep it short and sweet. The story of the tortoise and the hare. Write an inequality for when the tortoise is leading the race. Okay, so the tortoise, according to this key, is the green, right? And it looks like there's actually 2, right? So this is going to be an or statement, right? We've done this before. Okay, so it goes all the way up to 5. So we're going to say x, oops, let's not use a highlighter here. And it's going to be on the left-hand side, so that's less than. So x is less than 5, or x is greater than, what number is that? 10, on a 10. So x is greater than 10. Okay, and then it says, write an inequality for when the hare is leading the race. Okay, so now the hare is the purple line, and we can see that that time frame is going to be from here to here, right? Okay, and so that would be between 5 and 10, right? And we're just going to leave it like that. So between 5 and 10. And we didn't draw the lines underneath because at the 5-minute mark they're tied, and at the 10-minute mark they're tied. So we don't want to say that it's equal to, because the hare is not leading the race at 5 and 10, right? They're tied. Okay, so that's kind of how you work with interval notation. That's the quick synopsis on comparing linear and exponential functions, which is our learning target today, as you can see. The exit ticket is going to assess whether you can recognize and explain the differences between linear and exponential functions. So your assignment today, complete the exit ticket at the bottom. Let us know if you have any questions, and I'll see you tomorrow.